All right, so hopefully you've taken a moment to discuss your answers with a classmate. If you haven't, please do that. And turn the video back on when you're ready to continue. So what you're being asked to do here is, if I want to go from, let's say, the b value to the x value of the vertex, what can I do to the b value to get to the x value of the vertex in both these answers? Or if I have the x value of the vertex and I want to get to the b value, again, what do I have to do to the x value to get to the b value? So I can come up with a generalization that seems to work for both of these. And when you have an idea, then you will complete these problems here using the graphing calculator. And what I'm asking for in problem 6, the last problem is, did the idea you came up with, does it work? Or do you need to come up with a better way, a better rule for what do I do the x value, for example, to get to b, or what do I do the b value, for example, to get to the x value of the vertex? And this really is the one that is the important one for us, because if I give you an equation in general form and I want to get to the vertex, at this point my only option is to factor it, average the two zeros together, divide by 2, or add the two zeros together, divide by 2 to get the average. Plug that in and get the y value. So is there a better way of getting there, a more efficient way of getting there? So this problem here, or task here, is about investigating the relationship between the x value of the vertex and the b value, and to see what's going on. So go ahead and down your guesses and go to the graphing calculator for decimals and see if you came up with the correct answers or not for a rule. Turn the video back on when you are ready to continue. So I'm going to take a moment and just kind of show you the graphs, and that way when we go back to problem 5, we will have the correct answers. So the x value of the vertex for the first problem is positive 1. And the second one, the x value is positive 7. And in the third one, the x value is negative 8. So if I go back to the original problem, hopefully you came up with that the x value of the vertex for the first one here was 1. This one is 7. And this one is negative 8. So did your pattern that you came up with in problems 3 and 4 still work, or is there a different pattern that's going on? So please take a look at all 5 answers and see if you can come up with a way of going from, let's say, this is the b value, so going from a negative 2 to positive 1. Indicate that second equation is really the more important one for the work we're doing. And the negative 14 would be the 7, and then the last one is 16, and it'll be the negative 8. So those are the 3 new ones. The previous one was these answers here, which was 16. Again, is going to negative 8. So it's the second time that problem gave us the same answers, and we have negative 8, and then it went to positive 4. So give you another minute or so, kind of look at the pattern, and look for patterns, and see if it still works, or help the new one. Turn the video back on when you're ready to continue. So hopefully in this you notice that the signs change. So the b value is negative, the x value is positive, and the b value is positive, the x value is negative. So there's going to be at least a negative sign, or negative 1, basically, in our formula. Hopefully the second thing you notice is that the x value is actually half of the b value. So 2 divided by 2 is 1, 14 divided by 2 is 7, half of 16 is 8, half of 16 is 8, and half of 8 is 4. So basically, the b value, the x value is half of the b value, but also the sign changes. So we could write it as negative 1/2 times b. Maybe you wrote it as b divided by negative 2a. So if I divide the b value by negative 2a, I will get the x value. You could also write it as the opposite of b divided by 2a. I'm sorry, the opposite of b divided by 2. No, actually, no, opposite of b divided by 2. Sorry about that. So b divided by negative 2, and then here it's going to be the opposite of b divided by 2. So if I want to change the sign of the b to positive, and then divided by 2 to get the 1, or change the b to a negative 18, and then divided by 2 to get the negative 8. So 3 ways of writing it, they all will give you the same answer. If I'm going the other direction from the x value back to the b, what we're doing is we are multiplying, we're doubling it. So 1 times 2 is 2, 7 times 2 is 14. But also, not only are we doubling it, but we're also changing the sign. So we're multiplying the x, the x value, the vertex by negative 2. So in the next activity, which you would have received today, called Getting Ready Lesson 5.3, we're going to continue with what we talked about in the last activity. So, and I wrote these activities to be done in 2 different days, which is the reason why question number 1 is here. So hopefully you can write down the formula without going back and looking at the handout, but again, write down that formula. So we're going to begin with problem number 2. Can you identify the x value of the vertex based on what we just talked about? Hopefully your Desmos calculator is still open. You want to type these equations in and quickly check, make sure you have the right answers. And then what we're going to do in problem 4 is I'm going to change the general equation so that the a value is no longer 1. We're going to make it now 2, 3, 4, and 5. And the question becomes, if I change the a value to another number other than 1, how does that impact our reward? So in other words, it would be divided by negative 2, the b value divided by negative 2 to get to the answer. So like a here, but the negative 8 divided by negative 2, that's positive 4. So I stick in 2x squared minus 8x plus 15 in the calculator. Do I get an answer of positive 4? And if the answer is no, then the only thing we're going to change here is add it in a value. So how can you figure out how that a value is being used to change that final answer based on what we've already done? So that's what you're doing in problem 4, is trying to establish what's going on. So when you're finished with this page here, the idea is that you have a rule that will give me the x value of a vertex no matter what the a value is when the equation is written in general form. The second part of the activity, this goes back to the quadratic formula, which you were asked to work on earlier in the week. And we're going to be looking specifically at one piece of the quadratic formula, which is the b squared minus 4 times a times c. It's called the discriminant. And what I want us to do in this problem here is take a look at the equation and how can b squared minus 4ac help me determine how many zeros it's going to be, how many times that parabola is going to cross the x-axis. So to be able to do this, you need to identify the a, the b, and the c value, and you're going to plug it into b squared minus 4ac and get the answer. And then once you've figured out the answer for that, then you will plug the equation into the graphic calculator to see what you get. And what we're trying to figure out is there a pattern between the answers we're getting for b squared minus 4ac and the number of zeros that we're getting based on the graph. So go ahead and use the discriminant b squared minus 4ac to figure out the answer to problem A.
go back to the Desmos, stick in the equation, and see how many zeros you get. And then turn the video back on when you are ready to continue. So this is the only problem I'm going to do on the second page, just to again kind of demonstrate what you're supposed to do. But the idea, again, is when you're finished, you should be able to find the answer to the discriminant, and based on that answer, it will tell you how many times the parabola across the x-axis, which we call the zeros. So the a value is 1 in our general equation, b value is -12, and the c value is 27. So the discriminant is b squared minus 4 times a times c. When you're, as I've said before about these exponents, anytime you have an exponent, I put the number in parentheses. Just do whether it's positive or negative. If you leave the parenthesis off, especially if it's negative, you'll definitely end up with the wrong answer. So -12 squared minus 4 times 1 times 27. This is 144 minus, and this is 108. So if I subtract the two things, I get 36. So that is my discriminant. If I look at the graph, touches the x-axis twice. It touches a positive 9 and a positive 3. So the answer to this problem would be there are 2 zeros. And then you move on to the problem B, and you do the same steps. Determine the discriminant, plug in the equation in Desmos, determine the zeros, and then when you're done with the problems, look for a rule. I think if I remember correctly, at the bottom of the page, it actually asks you like 3 statements, and you're supposed to fill in the blanks to finish off the rules. When you're finished with that activity, then move on to the next content block. But I would definitely check with a partner in class, make sure you both have the same conclusions about the discriminant.